Today let's try to solve another Leetcode problem 208, implement trie. So for a trie, it is also called prefix tree. So for this problem, it is a very basic Leetcode problem of how to use a trie. Yeah, now let's get started for this problem. Yeah, for the trie, normally we're gonna prepare a trie node because basically this is a data structure. We need to have a trie node, and after we have the trie node, we're gonna use the trie node to have an init and do the following functions. Yeah, and those functions are the very basic functions. Yeah, it's very similar like the insert search or start with. You always go through from the root to its children. Yeah, so I'm gonna prepare a trie node. So for the trie node, it is a class. Yeah, and inside the init, I'm gonna prepare this structure. Yeah, this data structure of the trie node. It's gonna have the children would be an empty dictionary, and it also has the add word. So it's gonna check if this letter is the add of a word or not. So from the beginning, it's gonna be the false. Now we need to prepare the init inside the trie. So I'm gonna use a self.root should be equal to the trie node. Yeah. Now I'm going to use the insert function. So basically this insert function is to insert a word inside of trie. Yeah. So I'm gonna prepare a temporary variable as current. It would be the self.root. Now I'm going to loop through the word. So for w in word, so if yeah, let me use a character C, not a w, because yeah, this is a character inside a word. So if C not in current dot children, so this means I needed to prepare a empty trie node. Yeah, so the current dot children C should be equal to the trie node. Yeah, if I prepare an empty trie node, I would to put the letters inside. Yeah, because this is the insert. Yeah, if it is not, yeah, if it's children, if there's no letters for its children, I need to prepare an empty trie node, and then I would to insert the letters inside it. Yeah, so basically it's gonna be current. Yeah, because here for this one, actually, I've already inserted the letter, but inside it is an empty, yeah, trie node. Now I need to shift the current to the, yeah, I need to shift the current to the current dot children C, because now I have it. Yeah, this means if I don't have it, I will init. If I have it, I will go for it directly. Yeah, so the current should be equal to current dot children C because I have this letter C. If I prepared everything right, I just need to check the add of the word. So it's gonna be the true because from the beginning it is a false. Now it should be true. Yeah, so this is the insert. Now I need to prepare the search and start with. Now let's just start with the search. Basically, the search is similar to the insert. Yeah, because for the search, we also need to prepare a current. It will be equal to the self.root. And now we're gonna do the similar operations. But for here, if this letter is not inside self.children, this means we didn't find it. Yeah, we can return a false immediately. So otherwise, we're gonna insert it. And finally, we just need to check if this word is actually a word inside of the trie. So we need to check if this current dot add word equals to true or not. If it is equal to true, it means we already find a word. If it is not equal to true, it means it is just a prefix of a word. It's not the word itself. Yeah. Now let's continue with the start with. The start with actually is a prefix. Yeah, because this is a prefix tree. Let me just copy the same code and try to finish the start with. So for the start with, it's gonna be the same. We're just gonna tag, yeah. So if this is say inside of the word, so currently it is not word, it is a prefix, yeah. So if for say inside of the prefix, if say not in the current dot children, yeah, if it is not inside, it means it is not start with this letter, this prefix, yeah. So we're gonna return a false immediately. So otherwise, we're gonna continue to check the next letter inside of the word, inside of the prefix. So the current should be equal to current dot children for this character C. But the final result would be just a true because we don't need to check. Yeah, because this is just a start with. As you can see, compared with the three functions, insert has more things to check because we basically need to insert a letter inside the try. And for the search, we can save something. We don't need to use so many check. We just need to return true or false. And finally, we just need to check if this is the header of the word. And also, you can check the start with. It's also similar. But for the finally, we just need to return a true. Yeah, if we didn't return a false from here. Yeah, it means for the prefix, actually, we have the prefix like that. If we didn't have it, we're going to return a false immediately from here. Yeah. Now let me just run it to check if it works. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as it passed all the testing cases, and as you can see, it's also pretty fast. Now let's analyze the time complexity. So for the time complexity, we're gonna use the word.less and prefix.less. Basically, for this insert operation, this is for preparing the try node. Yeah, for the insert operation, if we were to insert a word, yeah, so we don't need to prepare the init, yeah, because init didn't consume the time. We just need to take care of the insert, search, and start with. Yeah, let's check the insert. So for the insert a word, if the word less is let's say n is the word dot less. So if we were to insert that word, so the time complexity is actually just on. And similarly, you can see the structure is exactly the same. So for the search and start with, it's also on. Now we're gonna check how many calls. So there will be 3 times 10 to the power of 4 calls. So it means the time complexity is n times m. So m is how many calls. So it means 2000 times 2000 times 3 times 10 to the power of 4. So actually it is not a big number. So it is just it is a big number, but for the Leetcode actually it passed. Yeah, it is like 6 times 10 to the power of 7. It is a very big number. Yeah, because it has so many calls and the word.less is 2000. Thank you for watching. See you next